Okay, so let's look at this problem number 2 from class from yesterday. And several of you have asked me to actually verbalize my thoughts. So you have a ball that's projected horizontally from the edge of a table that is 1 meter high, and it strikes the floor at a point of 1.2 meters from the base of the table. What is the initial speed of the ball, and how high is the ball above the floor when its velocity vector makes a 45-degree angle with the horizontal? So a ball is launched horizontally. So here's our table. So we have a table, and if it's launched horizontally, this is the direction it's going to initially launch. So our V initial in the X direction is equal to our V initial, because our V initial in the Y direction is equal to 0, because it's not going up or down initially, it's going horizontally. We talked about that in class. Our A sub X is equal to 0. Our A sub Y is equal to negative 9.8 meters per second squared. So it's going to fly horizontally and make a projectile, a curved path, a parabola, because of gravity. So our Y is minus 1 meters because it's going down, and our X is equal to 1.2 meters. So in our A direction, we don't have any things to break apart in angles, so it's got to go through. We're trying to find our V initial, but we know that is equal to our V naught X. So we need to find our V initial in the X direction. So we have to work with our X equation. So X is equal to V naught X times time. This 1/2 A sub X V squared. I know that term is 0. Because our acceleration in the X direction is 0. I know this is 1.2 meters is equal to V naught X times time, so I need time. So I had to go to my Y equations. Well, I know my Y, and I'm trying to find T, so my best equation is this. And I know my V initial in the Y direction is 0, because it's moving horizontally. So my negative 1 is equal to 1/2 times a negative 9.8 times T squared. So that means 1 is equal to 4.9 T squared, getting rid of the negatives on both sides. So 1 over 4.9 is equal to T squared. Square root that, punch in your calculator, and you're going to get a T equal to 0.452 seconds, somewhere in that ballpark. Now that T goes up here, so 1.2 meters is equal to V naught X times 0.452 seconds. So our V naught X is equal to 2.66 meters per second, or V initial is equal to 2.66 meters per second. So that's how you're going to do part A. For part B, I think that's where some of you are getting stuck. And then we talked about this in class. As you work your way down, these velocity vectors when it's steeper. So somewhere in here, this velocity vector makes a 45-degree curve. So we're going to call this point A and point B, or however you want to label it. But I want to look at that triangle better. So someplace, this velocity vector is going to make a 45-degree angle with the horizontal. So this is our Vx, and this is our Vy. We know this is equal to 2.66 meters per second because our acceleration in the X direction is 0. So our velocities in the X direction will not change. So we need to find this to be able to work with H. So we're trying to find this height right here. So I need to find that Vy. So there's two ways of doing it. One, if you know that this is 45 degrees and this is 45 degrees, you know your two legs are equal, so Vx is equal to Vy, which equals 2.66 meters per second. But let's say that you don't realize or understand that trig there. So you have this triangle. Well, I have the two legs. So tangent of theta is equal to opposite over adjacent. So tangent of 45 degrees, whatever angle you have, is equal to Vy over Vx, or that is equal to Vy over 2.66. So Vy is equal to 2.66 times, times tangent of 45, which tangent of 45 is 1, so Vy is equal to 2.66. Okay, so you can work it that way as well. If I don't give you a 45-degree angle, so let's say this is 30, you could put 30 in there, that'll give you 50, whatever that angle is. You can use tangent if you know the two legs to find the other leg. So we know that our Vx and our Vy are both 2.66 because it's a 45-degree angle, but again, you can use tangent to find that leg. So I'm trying to find Y. So if I'm looking at the picture, I want to find out really how far does it fall from A to B. So in reality, what I'm trying to find in this math is I'm trying to find this distance here, okay? How far does it fall from A to B? So I'm trying to find that blue, so let me just leave it in blue. I'm trying to find that blue height. I know my velocities at A and B. So I know that my Vy at A is equal to 0. My Vy at B is minus 2.66 meters per second. So my Vy final squared equals Vy initial squared plus 2a sub y times y. And I'm trying to find that blue y. So I have a negative 2.66 squared plus 0, equals 0 plus 2 times the negative 9.8 times y. Punch that in the calculator, you get y equals a negative 0.361 meters. Now that is this height right here, but I'm trying to find the black h. I'm trying to find this height right here. This whole thing is 1, because that's the height of the table. So that means h is equal to 1 minus 0.361 meters, or h is equal to 0.639 meters. Email me or try to get a hold of me and let me know if you have any other questions.